Okay, this is problem 875 from the homework. We have this problem about temperature being modeled by a sine function. So this problem is a little confusing if you look at the answer in the book, because the problem says to assume that there are 365 days in a year, but if you set up the model like we showed you in the other videos, you'll get a slightly different answer. So I'll explain that in just a little bit. First, let's look at the data in here. So we have the highest average temperature of 85 degrees on day 197 and a low of 37 degrees on day 17. So if I'm going to sketch a model of that, I have day 17 with a low of 37. I have day 197 with a high of 85. And so to figure out the amplitude, I want to find the difference between 85 and 37. And if I subtract those, I get 48. If I split that in half, I get 24. So 37 plus 24 means my midline is at 61. So I did 85 minus 37 to get 48. I divided that in half. And then I took 37 plus that answer, 24, to get my midline. Okay, and then my amplitude is the half, or the distance from the midline to the high or low. Now, on a graph, we know if we have a high and a low point, we only have half of a cycle. So we have something like this. We need to finish the cycle, we'd need to go back down to a low point, or we'd need to go back up to a high point. So if half the cycle is from here to here, which is a difference of 180 days, then it would make sense that the whole cycle would be another 180 days. So 360. And this is where the problem is a little confusing, because we're talking about 365 days in a year. And this is the deal with models. They're not perfect. So if you use what the book is saying, assume 365 days in a year, we can sort of disregard this stuff. If you wanted to calculate your own version, you're going to get a different answer than what the book has for the homework help. And part of the reason you don't want to use 360 is because if you use that to model temperature over year, it would get really off really fast. And like 5-10 years would be pretty far off from what it should be. So we're going to write a model using 365 because it's close enough. That's the best answer I have. I know it's not a good one. So if we do that, we know 365 is equal to the period of the cycle, and P times B equals 2 pi. So if we take 2 pi and divide it by the period, this is going to be our B value, 2 pi over 365. The other thing about these equations is that you can write them lots of different ways. I tend to pick the first key point after 0, and so I'm going to use this point here, the low point, as my start of my equation, which means that I have an upside down cosine graph. So I'm going to use a negative cosine graph, and I know my amplitude is 24. I said cosine. I know my B value is 2 pi over 365, and then I'm going to take x, because 17 days is shifted to the right 17 from 0, I'm going to say x minus 17, and then my midline is 61. So this would be an equation that would model that graph. And then use the equation to estimate the high temperature on Valentine's Day, day 44. So on this graph, the x-axis is represented by days, the y-axis is represented by temperature, so we would put the 44 in for x here and just solve this equation. Because we're dealing with pi and radians, you want to make sure that your calculator is set to radians mode. And then you just got to plug it in. So you'd have 44 minus 17, you'd have 27. You'd multiply 2 pi over 365 times 27. Find the cosine of that answer. take it times negative 24, and add 61. And if you do all that in your calculator or plug it into decimals, you would get about 39.5 degrees. I hope that's helpful. If you have questions, let me know.